Okay, so today we're going to be talking about velocity and speed. So let's first define the two. When we're talking about velocity, what we're talking about is a displacement occurring over time. Okay, so this is a displacement. Okay, so that's a vector divided by time, which is a scalar. So anytime that we take a vector and we divide it or multiply by its scalar, we get another vector, meaning that it's got both this magnitude part, the how big, how fast, how much, and then the directional aspect of it. But then we also have speed, which is a change in distance occurring over time. So distance being our scalar, and then time also being our scalar. When you take a scalar and divide it by another scalar, of course, you're going to get a scalar. Okay, so this only has the magnitude part. So that's the how big, how fast, how much. So when we're talking about average velocity, okay, average velocity is defined as the change in distance, the change in displacement divided by time. Now, a couple things to point out, that we will use the v for both speed. So if we're talking about speed, we use the letter v, or velocity, we use the letter v. Okay, so the v for velocity makes sense, the v for speed, because simply if you look at a number, let's say 3 meters per second, if I just see the 3 meters per second, I say, well, it's going 3 meters per second, and that's its speed. But if I see 3 meters per second with either a plus sign or maybe a minus sign, or maybe even I'm going to give a direction, then I could say, okay, well, the magnitude of the velocity is 3 meters per second, and then the direction is east. But in either case, it is the change in distance or displacement divided by the change in time. And then, of course, change means y2 minus y1, so this is the last minus the first. The F stands for final, and then the I stands for initial. Okay, so if we're looking at this, you should get a kind of idea that this is very similar to delta y over delta x, aka the slope of the graph. So remember that when we did the truck and buggy lab, when we graphed distance versus time and we found the slope of it, we said that slope represents the speed. Now if we graph displacement versus time, then slope represents the velocity. So it depends on whether this is our vector or our scalar. Okay, so let's do an example here. So Tom gets on his bike at 12 in the afternoon and begins riding west. At 12:30 he has ridden 8 miles. So we want to know his average velocity. Okay, and another thing talking about an average, a way that we show an average, so AVG, right? That's what I had on the previous one. I can also use the bar over it. So that bar tells me I'm talking about an average. So what we have here is we have the 8 miles, so that is our displacement. Okay, so that's our change in displacement. And then we also have a change in time, right? The delta t being 0.5 hours from 12 to 12:30. Okay, now if we want to express it in minutes, as I have below, that's 30 minutes, of course, and then I get a direction, I get a magnitude, and then I get a direction. So there's my average velocity. Now if I'm trying to do it in meters per second, well, this is a unit conversion. So what I did is I set up 0.27 miles per minute, and I set up my two conversion factors. I have the miles over here, 1 mile, the bigger unit of distance, and then 1 minute, and then, and then my units of miles canceled out, and my units of minutes canceled out. So if I do 0.27 times 1610, and then divide that by 60, I get 7.245 meters per second. And of course, we want to add, if we're talking about velocity, the west. If we're talking about speed, then just the 7.245. So average speed is the total distance traveled divided by the total time of the trip. So if we want to put that into an equation, okay, it is the total distance, so I'm just going to write it as d divided by the total time. Now, another way of calculating any average, right, if you have two test scores, let's say you scored a 100 and a 90, and I asked you what's your average test score. Well, what you would do with those two numbers, right, is add them up and divide by 2. So another way of figuring out an average speed, if I know that I started with, let's say my initial is 0 and my final is 10, and I asked you on average how fast you were going, well, you would simply say 0 plus 10 divided by 2, or 5. So my average speed would be 5 meters per second. Now, since we're talking about speed, we're really only talking about the positive quantity, so it doesn't make sense to say a negative speed. So let's say we have an example here. Sally gets up one morning and decides to take a 3-mile walk. She completes the first mile in 8.3 minutes, the second mile in 8.9 minutes, the third mile in 9.2 minutes. Now, this probably is more like a 3-mile run, but nevertheless, we could still figure out the average speed. So if I want to find the average speed, remember, it's the total distance divided by the total time. So in this case, what I would do is I would take the total distance, the 3 miles, and I divide it by the total time. So I would add up these 3 times. And if I do that, I get an average speed of 0.11 miles per minute. Now, if I want to do this in meters per second, why don't you take a minute, pause the video, and try to do this on your own. Okay, so let's see if you got what I got. So if you set up the 0.11 miles per minute, and you do your conversions, once again, your miles cancel out, your minutes cancel out, and we do the 0.11 times 1610 divided by 6d, I got 2.95 meters per second. So a car travels around the corner by traveling 50 meters east, then 50 meters north. It takes the trip in 50 seconds. Okay, so vroom. All right, so notice that this is very much like a geometry problem, right? So the distance traveled is, of course, 50 meters. That's going to be 100 meters, right? Because it went 50 meters this way, then 50 meters that way. So the total distance is 100. Now the displacement, however, okay, from where it started to where it ended, you have to do the a squared plus b squared equals c squared. So when you do that, you get a distance of the 100, as I said, and a displacement of 70.7. So now when I'm trying to figure out my speed and velocity, well, my velocity would be the distance divided by time. So the 100 divided by 50 seconds, or 2. My velocity will be the 70.7 divided by 50, or 1.4 meters per second. Now, in order to make these displacement vectors proper, okay, we would say, you know, something like, for now, we'll just use northeast, but later on we'll actually describe it with an angle, because it's not exactly northeast, but it's in between north and east. All right, so this is one last example. A bird travels in a straight line from where the car ends up to where it ends, starts up to where it ends, and it makes the same trip, same time as the car. Now, the question is, does it need to go faster or slower? So this is talking about the speed. So if we average speed, okay, the distance it traveled, it didn't go the 100 meters. So it only traveled the 70.7. And so by doing so, it took a shorter distance, therefore it doesn't have to go as fast. Okay, so its speed is going to be less. And it's going to have the same amount as the velocity. So the velocity and speed can be the same value as long as you're going in a straight line, which the car did not originally go in a straight line. Okay, so the velocity, the average velocity is how fast we would go in reaching in the shortest path. Okay, so think about it as a straight line shot. Okay, so this is the summary of the two. Okay, so looking at this velocity time graph. So if we're looking at this velocity time graph, obviously this object is changing its speed. Okay, but I want to talk about what we can do with this. Okay, so first of all, we can find the distance traveled. Okay, now you may say, well, how do I take this and find distance traveled? The distance traveled will represent the area, I don't know what's going on with my pen, the area underneath the line. Okay, so if you find the area underneath the line, so if I want to find how far it goes in the first 3 seconds, I can see that I have a triangle. And I can find the area by simply saying 1/2 base times height. So in 3 seconds, I could do 1/2 of 3 times 30, and it therefore went 45 meters. Okay, so that's what I could do with the area. Okay, now or when you have, since this is velocity, a vector, you can obviously go in the negative direction. So I would just subtract that area. The displacement, right, is also the area, but we have to consider the positive or negative value. Okay, so that's what this is saying. The area on top is positive, the area on bottom is negative. And then the last part is the average velocity. Okay, so the average velocity is a little bit more challenging, because we would have to first find the total displacement. So I would find this area. I could break this up into a bunch of shapes, right? I could break it up into, I see a triangle here, I see a rectangle there, I see a triangle here, I see a rectangle here, I see another triangle, and this would all be positive displacement. And then the little triangle here would then be negative displacement. And if I take the number of all these areas and subtract the area on this, I would get my overall displacement. And you could also argue the same thing about finding the average speed. The only thing different here is I would take this distance traveled and add it on top of that. Okay, so that's all for today. I hope that you found this informative, and we will see you in class tomorrow. Okay, take care. Bye-bye.